Hello and welcome to Season 3 of the Lighthouse Project. Today, we are going to discuss how we can train and fine-tune large language models in a more sustainable way. AI is becoming increasingly essential across many sectors, but as this technology advances, so do its environmental, social, and economic impacts. The challenge we face is finding ways to reduce these impacts while continuing to drive progress in AI technology. Sustainability fundamentally means balancing environmental, social, and economic aspects. From an environmental perspective, it's important to conserve resources and protect the natural environment. As AI technology advances, energy consumption is increasing, so efforts to reduce its environmental impact are crucial. On the social side, maintaining fairness and upholding social value is key. Since AI is trained on the vast amounts of data, ethical issues and data bias can arise, and addressing these challenges is vital. Finally, from an economic perspective, while technological advancements should generate economic benefits, it is also important to reduce the economic burden, enabling small business and researchers to access AI technology. Thus, sustainability is not a simple concept. It requires balancing multiple dimensions and addressing complex challenges. In relation to this, we can refer to the UN Sustainable Development Goals established by the United Nations in 2015. The SDGs consist of 17 goals to be achieved by 2030, aimed at promoting sustainable development across three dimensions: environmental, economic, and social. These goals address a wide range of challenges such as climate action, providing decent work, and reducing inequalities. The SDGs offer a framework for creating a sustainable future where we protect the environmental, uphold social fairness, and promote economic growth. They guide us toward achieving sustainability in a holistic and balanced way. Now, let's take a look at how AI impacts sustainability. AI can have both positive and negative effects on the UN SDGs. According to one study, AI can act as a positive enabler for 134 of the SDG targets, while negatively impacting 54 others. For example, in healthcare and education, AI can provide innovative solutions that expand access to quality medical services and educational opportunities. On the other hand, the massive energy consumption required to train large language models can negatively impact environmental goals, which focuses on addressing climate changes. Thus, while AI can promote sustainability in various sectors, it is equally important to find a way to mitigate the environmental burden it creates. So, what exactly is sustainable AI? Sustainable AI refers to considering environmental integrity and social justice throughout the entire life cycle of an AI product, from ideation to training, retraining, deployment, and maintenance. It goes beyond merely advancing AI technology, focusing on designing and operating AI in ways that positively impact the environment and society. More specifically, sustainable AI involves minimizing energy consumption during the development and operation of AI systems and exploring technological alternatives to reduce carbon emissions. It also emphasizes building fair AI systems that are free from bias by considering data ethics and inclusivity, ensuring that these technologies reflect diverse social backgrounds. This approach aims to ensure that AI contributes to the achievement of the SDGs while minimizing any potential environmental and social downside that could arise. So, what about large language models? As we know, the three key components of large language models, model architecture, GPUs or TPUs, and big data, have a huge impact, particularly from a sustainability perspective. First, large language models with complex architecture require longer training and fine-tuning processes. This leads to massive consumption of computing resources, which can significantly impact the environment. The surge in energy usage results in increased carbon emissions, negatively affecting environmental sustainability. Second, the high-performance hardware needed to train such large language models, like GPUs or TPUs, comes with substantial economic costs. As AI models become more advanced, they demand greater computational power, consuming more resources and posing challenges to economic sustainability. The high cost of a large-scale AI system can create access barriers for smaller companies and researchers, concentrating technological advancements in the hands of a few large tech firms. Lastly, the use of big data in training large language models can raise several data-related issues. This dataset often comes with challenges such as privacy concerns, data bias, and data quality, which can lead to ethical problems during the AI training process. Therefore, as we continue to advance large language models, it is crucial to find a solution that not only reduces the environmental and economic burdens, but also address the ethical concerns surrounding data usage. Sustainable AI development must ensure responsible data practices while mitigating its broader impacts. As we can see in the diagram, developing a large language model involves several stages, starting from raw data, training for pre-trained large language model, and training for fine-tuned large language model. Each of these stages comes with its own environmental, economic, and social sustainability challenges. The training phases poses the biggest challenges of the sustainability of the large language models. During training, vast amounts of data are processed, and optimizing the complex model architecture consumes a significant amount of time and energy. This leads to a sharp increase in energy consumption and carbon emissions, which have a substantial negative impact on the environment. Now, let's explore the sustainability issues in the training process and discuss potential solutions to address these challenges. One of the biggest challenges in training large language models is energy efficiency. The training and inference process for large language models require massive amounts of electricity. And since much of this energy still comes from fossil fuels, it has a negative impact on the environment. Specifically, as shown in the table, it is estimated that training a 7 billion parameter model to 1 million users require approximately 50 megawatt-hour of energy. This figure demonstrates that even models that are not at the top tier in size still consume large amounts of energy. As large language models continue to grow, the energy requirements are likely to increase, making it essential to optimize energy consumption during training and inference processes. As AI technology evolves, optimization strategies to reduce the energy footprint are crucial to ensure environmental sustainability and to support the broader positive impact AI can have across various fields. One solution to address this challenge is model compression techniques. Model compression reduces the size and resource consumption of large models, effectively decreasing the energy usage during both the training and inference processes. Specifically, the paper titled Model Compression and Efficient Inference for LLMs or survey delves deeply into compression and efficient inference methods for large language models from an algorithmic perspective. Model compression techniques can be broadly categorized into quantization, pruning, knowledge distillation, compact architecture design, and dynamic networks. These approaches are critical in enhancing the efficiency of large language models and represent key technical solutions for advancing AI technology in a more sustainable manner. By implementing these techniques, we can optimize large language models and mitigating the environmental impact associated with their growing energy demands, ensuring AI continues to progress in a sustainable way. Another environmental impact of training large language models is the energy footprint and carbon emissions associated with the process. Research indicates that large language models training consumes substantial energy not only during the final training phase, but throughout various stages such as initial model deployment, hyperparameter optimization, and data preprocessing. This means that a lot of carbon emissions are generated across the entire large language model training life cycle. Therefore, it is crucial to accurately assess the energy consumption and carbon emissions throughout the entire life cycle of large language models. To address these issues, several strategies can be implemented, such as developing more efficient algorithms, optimizing research through distributed learning technologies, and utilizing data center powered by renewable energy. One specific solution to this challenge is the use of tools like Carbon Tracker, as proposed in Anthony's paper. Carbon Tracker allows real-time tracking and management of carbon emissions during the AI training process. This tool helps visualize the environmental impacts of AI model training and supports optimization efforts aimed at reducing the carbon footprint. By leveraging tools like Carbon Tracker, the energy consumption and carbon emissions at each stage of the AI training process can be closely monitored and managed. This makes it an essential tool for sustainable AI deployment, enabling researchers and companies to train models efficiently while fulfilling their environmental responsibilities. From a social sustainability perspective, important challenges also arise, one of which is data ethics and privacy concerns. The data used to train large language models may contain sensitive personal information. If this data is not properly managed, it could lead to privacy violations or ethical issues. Large language models are trained on vast amounts of data, and there is a risk that this data could include information collected without consent and biased data sets. This can lead to biased predictions or incorrect decisions that disproportionately affect certain groups, raising serious concern about fairness and reliability. Ensuring that large language models are trained with ethical consideration in mind, such as safeguarding privacy, obtaining proper consent for data use, and addressing bias in the training data, is critical for building socially responsible AI systems that uphold trust and fairness. Therefore, when training models, it is essential to comply with data protection regulation and implement thorough measures to safeguard personal information. This includes data anonymization, proper consent procedure, and enhanced data security policies. Without these ethical considerations, it is impossible to ensure social sustainability, and the reliability of AI technology can be significantly undermined. To address these concerns, transparency tools like model cards can be utilized. Model cards provide a transparent overview of the data set and training method used for an AI model, helping to address issues related to the data ethics. By clearly explaining what data was used and the environment in which the model was trained, model cards help reduce the risk of biased data usage and ethical issues. Such tools contribute to building more socially responsible AI systems by promoting transparency, accountability, and fairness in the training of AI technologies. Additionally, bias in training data poses a risk to the fairness of large language models. Since large language models are trained on a vast amount of data, if that data is biased or unbalanced toward certain groups, the model can unintentionally generate biased outcomes. This bias can lead to unfair results in various decision-making domains where large language model can be applied. To address this issue, it is essential to incorporate various bias mitigation techniques and ensure balanced data during the training process. Tools like AI Fairness 360 and Microsoft Fairlearn can be employed to help guarantee the fairness of AI models. These tools are designed to analyze and correct biases that may arise during model training or in the outcomes. By using these tools, developers can detect potential bias in the data or model performance and apply corrective measures, ensuring that AI systems produce fair and equitable results. This is a crucial step towards building responsible AI that operates ethically and inclusively across different applications. One of the biggest challenges in terms of economic sustainability is the accessibility of AI technology. Currently, advanced AI technology are concentrated within large tech companies, making it difficult for small business and researchers to access cutting-edge AI advancements. This is primarily because developing and training large language models require immense capital, high-performance hardware, and substantial infrastructure. Large tech companies possess a necessary resource such as high-performance GPUs or TPUs and vast data sets to train large language models. In contrast, small businesses and independent researchers often lack these resources, creating a significant barriers to developing or utilizing the latest AI technologies. Therefore, improving access to AI technology and enabling participation from a diverse range of companies and researchers has brought attention to the importance of open platforms and open source projects. Platforms like Hugging Face plays an important role in addressing these accessibility challenges. Hugging Face provides a wide range of open source models and tools, making it easier for small business and researchers to access advanced AI models. Through Hugging Face, anyone can access state-of-the-art large language models and fine-tune them on their own data. Training large language models requires a lot of computational resources. The process typically involves handling vast datasets, utilizing high-performance hardware like GPUs or TPUs, and enduring long training durations. These factors are the primary contributor to the substantial costs associated with training and fine-tuning large language models. First, the larger the dataset required for training, the more resources are needed to process and store the data. Additionally, large language models have inherently complex and massive architecture, requiring extensive computation during training. The prolonged use of GPUs or TPUs not only increases energy consumption, but also raises the overall hardware costs. Moreover, the fine-tuning process itself consumes huge resources. Large language models are typically fine-tuned on specific datasets to adapt them to various domains, and this process often involves multiple iterations of training to optimize model performance. This leads to high time and cost expenditures, especially for smaller companies and independent researchers, making a considerable financial burden. These challenges underscore the importance of developing more efficient training methods and improving access to high-performance computing resources, especially for those with limited resources. Retrieval augmented generation is a technique that enhances large language models by retrieving information from external databases, reducing the need for extensive retraining while improving model performances. By utilizing external knowledge sources, RAG allows large language models to generate more accurate and relevant response beyond what the model has learned during initial training. Traditional large language model training involves using vast amounts of data, which requires significant resource and time. However, RAG enables large language models to access new information in real time by retrieving external data, allowing the model to understand up-to-date information or domain-specific details without requiring additional training. This approach maintains or even enhances model performance while reducing training costs and resource consumption. As a result, RAG enables large language models to perform effectively without the need for large-scale retraining, offering an economically sustainable solution for operation AI systems. This is particularly beneficial for small business or researchers as it provides the opportunity to operate high-performance AI systems without the need for substantial additional resources. RAG thus plays a crucial role in making AI development more accessible and efficient. In conclusion, training large language models requires careful consideration of environmental, social, and economic sustainability. As AI technology rapidly evolves, it is crucial to actively seek ways to maximize its positive impact while minimizing potential negative effects. This approach is essential for building a sustainable AI ecosystem which supports environmental protection, ensures social fairness, and improves economic accessibility. Sustainable AI has a potential to be a key tool in driving our society toward a better future. It should continue to evolve in a way that brings positive changes across various fields and benefit everyone. Thank you for watching, and we hope you are excited for Lighthouse Project Season 3 videos. We look forward to seeing you next time.